Good afternoon. Thank you for coming to listen to my presentation on cleaning with ice. So we'll start by saying ice, we believe, is at the forefront of a new technology that's set to change the way we clean the world. Before we talk about the innovation itself, let's go through some of the innovation over the years. We'll start with abrasive blasting that was invented in 1870. Typically, abrasive blasting has a higher media cost. It can produce harmful airborne contaminants, which can be hazardous to worker safety. It has a high cleanup and disposal cost, as well as you typically need full containment and negative air when you're blasting with abrasive. The next big innovation was pressure washing in 1927. Pressure washing uses high water consumption, and it varies in the technology, but it can use up to about 1,200 US gallons per hour. High pressures are needed, which decrease worker safety, typically up to or over exceeding 5,000 psi. Variable capital costs, so some of your larger systems can be in the low six figures. And it has a high disposal and containment costs. So if you think of using and creating 1,200 US gallons of water per hour water waste, now trying to treat that and then dispose of it can be very costly depending on what you're blasting. The next big innovation in 1947 was dry ice blasting. And some of the drawbacks of dry ice blasting can be a higher media cost. Full respiratory supplied air is required, especially in confined spaces where it can be dangerous to the workers. Dry ice can be in specific locations, difficult to find, purchase, and store, as well as dry ice supplements. So the question we asked ourselves before we started looking at this technology is really what happened to the innovation after that? Because it really started to slow down and stagnate. And one of the interesting trends that we started to see is after the invention of dry ice blasting, the innovation stopped nearly, and meanwhile environmental regulations continued to increase. Whereas now, introducing the benefit of blasting with an ice made from water, we feel that we're meeting a lot more of those environmental regulations that are being put on today. So now we'll introduce ice. A lot of people ask us, what is ice? They're so used to dry ice blasting referring to ice that when you start talking about just generic ice, our ice is not to be confused with dry ice blasting. Dry ice is a solid and compressed form of carbon dioxide, versus our ice is made from water, which is one of the oldest known substances to mankind. The ice we use is typically freezing water at a temperature about -5 to -7, so you can touch it, you can put it in your drink. The next big question people ask us is why ice? Why is ice made from water better than dry ice or abrasive blasting or pressure washing? Well, ice is actually a superior cleaning and deburring media. It's one of the only medias, well, it is the only media that actually exists in all three phases, which means it hits the surface as a solid. Then half of it, it turns into a gas, which evaporates, and the other half stays in a liquid form, which actually pulls all your airborne contaminants down to the ground and creates minimal airborne contaminants. Ice is the only media with 3 cleaning mechanisms. So the first is the bulk removal. When the ice first hits the object or the substrate that you're blasting, it removes the major particles. Each new piece of ice then acts like a bristle on a brush, scrubbing the surface. And then there's the final rinse where it turns into its liquid form and it creates a clean blasting surface. And as mentioned before, it produces minimal airborne contaminants. Yes. Typically, the pressure that we use is about 80 psi up to 150 psi. So it's very low, very low pressure. In CFM, we blast anywhere from 100 up to 300 CFM. Blasting with ice actually creates very little residual waste, and we have about, on average, blasting at 3 pounds a minute, you'll have around 10 gallons an hour of water residual waste. And of that, the easiest way to describe it is if you picture a Slurpee like you buy from 7-Eleven. That's what your contaminant looks like. It looks like a Slurpee right below where you're blasting. That's the color of whatever you're taking off, whether it's paint or bitumen or etc.
Question. How is that 10 gallons per hour compared to like traditional high pressure washer or water washing?
Example, high pressure water washing can consume up to 1,200 gallons an hour. So how can ice help me? A question that's always posed to us. Ice is a very low-cost media. Of course, it's easy to buy because you can buy it at any grocery store, but also you can make it yourself. With your own ice maker, you can make it for less than a penny a pound.
So you just need ice cubes?
Just ice cubes. Ice cubes, bricks of ice. I know in industrial cleaning, one of the things that people come to us all the time with is a lot of the jobs are on a weekend, for an example. And with dry ice, you have to buy it in a schedule. So if your delivery period is on a Monday and you're blasting on the weekend, not only do you have to wait for that long and factor in sublimation, but also if you run out on the job site, how do you get dry ice, for example, on the weekend? It's very, very difficult.
Does it need to be pure?
It can be made from any type of water source. Tap water, for example. A lot of ice is made from tap water. A lot of our systems now, the contractors themselves, whether they're in a plant or even in their trailers, they'll have their own ice makers, or you can put it in large totes, 300, 400, 500 pound totes that'll last for 4 or 5 days holding the ice. Ice is safe to operators. So a way we gauge media and how safe it is to an operator is, can you hold it? Can you, if it gets in your eyes, are you going to be okay? If you drink it, is it okay? Well, ice, of course, meets all of those. So ice is a very effective cleaning media, so it's actually, in a lot of cases, quicker to clean with ice than a lot of different other types of cleaning tools out there on the market today. In proper storage, which is a freezer, ice will last forever. And it has a low equipment capital cost, so the capital cost of the equipment to blast with ice is fairly inexpensive. So here's a video we did on introducing the technology.
It takes courage to innovate, to push the boundary of normal in order to create something special. To begin with a brushstroke headed into the unknown and come out with something revolutionary. We took that impossibility and created functionality, a masterpiece in its own right, a work of art that is as efficient and powerful as it is elegant and refined. We didn't just build another tool to clean with. We built a highly effective instrument with the unparalleled performance needed to tackle any job. A whole new ice age is coming, and it's going to change everything.
This is the technology used that we showed in the video. just some of the quick hits on it. It holds around 90 pounds of ice in the hopper. So that will allow, based on what you're using for your feed rate of ice per minute, allow the operator to blast for about an hour long. Yeah, we currently, it doesn't have a refrigerated hopper, but it's fairly highly insulated. So you can leave your ice in the hopper for about 3 hours in the hopper on a 40 degree day, and you're going to lose about 3 to 4%. It runs off typical 110 volt power. It has a 48-month warranty. It weighs 250 pounds. Operating pressures, as well as variable ice feed rate. Yeah, the particle size, so when you put your ice cube or your brick in, or whatever type of ice you're putting into it, it actually crushes it down, almost like when a rock crusher, for an example. And it has a particle size coming out the nozzle of about 0.3 millimeters in diameter. Sorry, almost 0.3 millimeters. So it's fairly small. We like to think it's about the size of a grain of rice. So that's the size of it coming out. We did have, of course, blasting with ice, there's some advantages and disadvantages we had to work with. Ice is very difficult to move through a hose because you're worried about the heat transfer of the air going into the ice and the melting, etc. So it needs to be run with an aftercooler, for an example. We did have a special set of nozzles actually developed for the technology. We brought in a gentleman that has the record for creating the gun with the fastest bullet in the world to properly go through and take the ice and see how fast we can get it going. And we actually excel our ice out of the nozzle. It's about 600 miles an hour. So it goes very, very quickly. So it's not something you want to get in front of. But other than that, if anybody has any questions or... Oh. Do you have a mic? Can you bring this, Jim? Yeah. So you need to have, of course, power, which is your standard 110 volt, and then a compressor of some size. If it's in a plant, a lot of times we just plug into plant air. Typically, I know one of our markets, is targeting industrial cleaning contractors. The standard compressor they have is like 120 psi, 300 to 325 CFM. So a lot of times that's what we run off of.
How is it better than dry ice?
It's in a lot of applications it's more effective and efficient. Just the way the ice works compared to dry ice. Of course, dry ice is a bit of an explosion on the surface, so the surface has to be much harder. Versus wet ice, we're having a transfer from a solid, and then it hits it and it has actual mass that transfers into it before it switches into a liquid or a gas. But also media cost is a big component to that. Of course, you can make ice for less than a penny per pound, and dry ice, I know where we're located as an example in Canada, in Vancouver, dry ice costs me about $1 a pound delivered. So it can be fairly substantial depending on where you're located. Yes?
What melt profile does that material make, and do you have any flash rust issues?
It depends on what you're blasting. We can't profile steel itself. There are some, we can profile plexiglass, for example. But when you're talking about, profiling metal, we can't do that. In terms of flash rust, typically what causes flash rust are the soluble salts in the surface after you're blasting that are in the pores. Ice does a very, very good job getting into all of the pores, and we can actually eliminate the soluble salt content which causes the flash rust. So depending on how well you're cleaning it, and after you're done cleaning it, keeping that area, free of contamination, you can really minimize your flash rust problems.
Hi, so from the video that I showed earlier, it looks like the common application of this equipment is to for cleaning of more of the exterior outside, cleaning up the dirt, the rust build up. And my question is, how abrasive is this process? Let's say if I were to clean a manufacturing equipment with like precise dimension, do I have to worry about the damage of the surface and coating and things like that?
So that can be fully controlled. We can clean as gentle as going over a board with fine wires and gauges, and we won't damage any of that, to the extreme that we can cut aircraft aluminum in half. So you can really vary the abrasiveness of the technology.
Okay, so that goes together with your variable. Just now you mentioned
variable ice hardness. You can choose, and it's a combination of a. Sorry. It's a combination of your pressure that you're using and your feed rate of how much ice you're using per minute.
Gotcha.
But it can be very controlled. And we've done systems for Ford Motor Company for deburring applications, for deburring gears, to Denso Bosch, cleaning fuel armatures. So we have done many automated systems as well, which we work on designing and creating.
When you're talking about the burring, it's for example for metal parts.
Yep.
Does it work? Small metal parts like CNC stuff.
Yep, we do a variety of deburring applications, from deburring micro gears to larger objects that are being machined. Yeah, we do. So we have some shots, and we actually have a video at our booth that shows some of the deburring applications that we do. 4090, which is just upstairs. Is there any other questions? Yes.
Have you done any kind of cleaning of big tank mixers, inside of the tank mixers, automation?
We've done Royal Dutch Shell. We've done some work in cleaning some of their big cylinder containers. Pulp and paper mills currently use the equipment in cleaning coatings, rollers, some of their big mixing pots. So this technology was actually developed by the Canadian Navy to clean in confined spaces, to clean with something that is not going to be dangerous for the worker. So that's kind of the basis of the technology. So anything that's a small space that you're trying to clean in, the technology excels in that.
Is that the only size unit? Do you have something more portable?
The unit itself right now, it's smaller than a shopping cart. So it's about 20 inches wide by 40 inches long by about 35 inches tall.
Could it be smaller?
It could be smaller. We have some smaller models we're working on now. And then of course we also have some larger systems that we use for more automated processes. We have some systems that actually create ice internally. So all you do is plug in a garden hose and then they just run 24/7 to minimize, of course, the operational costs.
Is the cleaning of the internal tanks, is it an automated process or it has to be done manually?
Currently it's done manually, but it's in this day and age, especially at this show, you can see it's fairly easy to automate and to create a system that could do that. Awesome. Well, thanks for coming and listening to the presentation.